This episode of the Farm Traveler Podcast is brought to you by Midway USA. You might know them because they have everything you might need for shooting, hunting, and the great outdoors. And now they also offer over 30,000 fishing products across 118 brands. They've got meat grinders, the AR-15 parts, reloading equipment, hiking boots, turkey decoys, ammo of all shapes and sizes. And I have used them for ammo, and a bunch of my friends and family have used them too. And now, if you're into fishing, they have over 30,000 products, including brands like St. Croix, Humminbird, Millennium, and a whole bunch more. And thanks to the Waypoint Outdoor Collective, if you go to midwayusa.com, enter promo code WAYPOINT at checkout, you will get free shipping on your order. Again, that is promo code WAYPOINT. Thanks again for Midway USA for sponsoring this show.
Support for this podcast comes from Twilio. Right now, businesses all over the world are trying to reinvent how they connect with the world. Whether you're delivering packages, treating patients, or running a global customer support center, your customers need you to invent new ways to stay connected. Twilio is the platform that millions of developers trust to build seamless communications experiences with phone calls, text messages, video calls, and more. It's time to build. Visit Twilio.com to learn more. That's TWILIO.com.
Support for this podcast comes from Velocity Global. 2020 has changed the way companies around the world do business, but your international growth plans don't have to wait. Velocity Global's international PEO solution enables you to quickly and compliantly hire overseas without using independent contractors or establishing a legal entity. Visit velocityglobal.com/expand to learn how international PEO simplifies global expansion in over 185 markets. That's velocityglobal.com/expand.
Most people have made up their mind. They've decided based upon the people they trust what that is. So whether it's somebody online or a website or a celebrity, they've shaped those decisions about food and farming. Gwyneth Paltrow has much more pull than I do. Dr. Oz, you name it. So this is really what we're up against as scientists and as farmers, is pushing back against a very social wave of what isn't necessarily the best information.
Hello and welcome to episode 75 of the Farm Traveler Podcast. I am your host, Trevor Williams. And do you know about the Disney Vault? You probably do. The whole thing, Disney takes a popular movie like Lilo and Stitch, or honestly, probably older than that, like Cinderella, or what are some older Disney movies? Lady and the Tramp, 101 Dalmatians, all that. They take those movies, they put them in a vault. 10, 15 years later, they remaster them, and then they go back on sale for new generations to enjoy. Well, today on the show, we're going back in time, back in the Farm Traveler Vault to only a year ago, and we're going to re-air an episode with the former guest, and that guest is Dr. Kevin Folta from the University of Florida. Now, I think there's a lot of stuff going on right now that this can kind of relate to, a lot of misinformation when it comes to science, especially with COVID-19. Also, with season 2, we've been covering kind of organic versus conventional agriculture. And I think this episode, it covers a lot of stuff with both organic and conventional. And also, Dr. Folta goes in depth on the science and kind of the history with GMOs and genetic engineering. And when we launched it a year ago in October, we had a smaller audience. Well, now, thanks to you, we have a much larger audience. And so I think a lot of the new people, a lot of new listeners need to listen to this. It's got a lot of great information from Dr. Folta. We're going to talk about genetic engineering, his work at the University of Florida, Frankenfoods, how we're actually starting to modify salmon. And so, we're like genetically engineering salmon, which is crazy and awesome. And also how we can really advocate for science and advocating for science in the agriculture industry. If you're a farmer or rancher, you'll relate to a lot of the struggles that Dr. Folta has. If you're a consumer, I really hope this kind of gives you a great peek into the eyes of agricultural educators, and that all the steps we're trying to go through towards educating you on where your food comes from and just how to fight all the misinformation. I know you hear that over and over again on this show, but I mean, we live in the era of fake news. And so we all eat 3 times a day, no matter who we are, where we are, our backgrounds, our beliefs, whatever. And so this is one of those things where there's a ton of misinformation out there, and really ag educators are doing all they can to fix that. Again, this is Dr. Kevin Folta from the University of Florida. And also be sure to check out his podcast, which we'll talk about it in our podcast. It's Talking Biotech. Before I forget, also, like with the Disney Vault, they go back and they remaster certain parts of the movies. Well, I went back and took out a lot of, my favorite lines, like, oh, that's cool, or that's really neat, or and all that stuff. I really hope you enjoy it. This is episode 75 with Dr. Kevin Folta, a blast from the past. Hope you enjoy it. Hope you learn a thing or two about GMOs and science and agriculture and all that great stuff. All right. Well, Dr. Kevin Folta, how are you doing?
I'm doing just fine, Trevor. Good to talk to you. This is really cool.
Hey, well, thanks for being on. So you are a professor and the department chair at the University of Florida, specifically the Horticultural Sciences Department. So it seems like on the internet, you are the go-to guy when it comes to gene editing. So before we dive into that, tell us a little bit about your background and kind of how you got started with the world of gene engineering.
Well, I should tell you right off the bat, I'm not the chairman anymore of the department. That ended about a year ago, but that allowed me to go back to my laboratory full time. And I got started with genes, genetic engineering, all that stuff when I was 10, and was very excited about recombinant DNA at 10 years old. The ideas of genetics and heredity have always been intriguing to me, like those old books where they would have the guy with too many chromosomes or not enough and missing, with the black bar over the eyes. I always thought that stuff was intriguing, and was very fortunate to study it through college and have great mentors throughout graduate school and wonderful opportunities to do this for a career. So I'm very grateful for that. And one of the few people I know who has known what he wanted to do his entire life and actually got to it.
So I actually graduated from UF, and I've got a minor in environmental horticulture. I graduated back in 2014. And you probably know him, Dr. Clark. He has a plants, gardens, and you class that I took. And it was really cool because every week he would bring plants. We would take home tomato plants, coleus plants, banana plants. It was really cool because it was like an entry-level class. And so you would have a whole bunch of people throughout the university to take that class. And it was a lot of really cool stuff. Have you worked with Dr. Clark on anything?
Sure. Yeah, we've had collaboration before, but mostly Dave and I spend time fishing and having a beer and watching football. So we collaborated on lots of different things, both in the university and out. And he's a really great teacher. He's been led that class for years now, and always is full. So hats off to Dave.
Yeah, it was a really fun class. All right, so in layman's terms, can you kind of tell us how gene engineering works? I understand that you take a gene from one species and you put it into another species. Like I was listening to one of your podcasts, I believe, and you take a gene from a bacteria, for example, and you put it into a plant, into their gene. So tell us how exactly that whole process works.
Well, it's really no different than word processing. You're essentially taking a sentence out of one script and placing it into another. And just like words in a book, the genes in a genome are all made up of essentially letters, these repeating codes of chemistry. And we think of that genetic code, and people have seen that G and A and T and C. It's those 4 chemicals, which are, glycine, guanosine, adenine, thymidine, and cytosine, that are their order of those G, A's, T's, and C's gives a very distinct code inside genetics. And so we can take the DNA, because DNA is DNA, whether you're bacterial or whether you're a virus or whether you're a, and so the DNA has kind of interchangeable parts. It's the fact that it uses the same kind of general mechanism to turn on and off. It means that we have inherently the ability to switch parts between one organism and another and see how that information behaves in a different context. It's like taking the parts out of, the bathroom out of one blueprint and placing it into another and having a house built with that one modification. So how it happens in real life is that in the laboratory, we're able to take a gene out of one organism, very easy to do these days, It involves that amplification method that they use in forensics. When they find a human hair and want to know the criminal, they can get the genes off the end of that hair. We're able to do this in the laboratory from any organism and take that amplified gene, place it into a compatible context of information, genetic information, and then we use a bacterium that does genetic transfers to move it into the plant cell where we want it to go. And other methods exist too that are a lot more random, but the using the bacterium called agrobacterium, he goes in and does the work for us. He moves the genetic material to that new organism. And then we can have a whole new plant where every cell contains all of that new genetic information that was installed.
You've probably heard this term before. You've probably heard it a ton, but frankenfoods. And a lot of people, like anti-GMO activists, will say, oh, well, you're taking the genes from one species to another. That's got to create some sort of Frankenstein plant. What do you say to those people? I mean, especially after you just said that the genes are totally fine. So what do you say to those people that kind of are fearful of the quote unquote frankenfoods from all this gene editing?
Well, I kind of love the term because if you think of the original book from Frankenstein, Frankenstein's monster was what Frankenstein created. Dr. Frankenstein made Frankenstein's monster, who turns out that when it got out of the laboratory, actually wasn't necessarily a bad thing until the townspeople decided to destroy it. And when they came after it with torches and pitchforks, then things broke bad. So in a way, it fits really well because it isn't inherently wrong. I really kind of don't like those terms because they are terms of derision. That these days we have to be able to genetically adjust plants and animals as fast as we can to meet the challenges that are happening and to feed more people. And to tie the hands of science that can solve a problem is really unethical in my opinion.
What would you say are kind of the current issues going on right now? Like, what's the current state of genetic engineering? Are there any recent breakthroughs, or what's kind of going on there?
Oh, you mean today or yesterday?
Oh, I mean, both. Why not?
It is that fast and furious. The new thing that's happening, you can sometimes find referred to as gene editing, or sometimes by the technical names of the different methods, CRISPR or TALEN or things. But gene editing, if what I described before was word processing and moving a sentence from one book to another, this is erasing a single letter out of a book. And what's so cool about that is that when you erase a single letter out of a gene, out of that genetic code, it sometimes can throw off that gene, that it makes things kind of shift in a way that doesn't work, and it eliminates the function of that gene. And so this is the newest technology. It doesn't leave any goodies behind. So in other words, you can make this correction or this change, and there's no evidence that you did it other than the changes there. There's no extra genetic hardware around, which is what happened in old school genetic engineering, and some people found that objectionable or potentially problematic. This new stuff removes all of that questionable material. And it wasn't questionable for scientists, but it was for the public. But the new methods take that out. So this new method has been used in solving all kinds of problems in plants. It's been used in disease for humans. There are trials for sickle cell anemia. There are trials for, we know babies that have been cured for leukemia, which in some cases required the use of these technologies. And this is real, this is now, and it is so fast that you're hard-pressed to go on Google News and put in CRISPR, CRISPR, or gene editing. You pull up a news story every single day of a problem being solved. It is the hot time for genetic engineering.
That's really good to hear. So this might have been news from last week, but I heard on one of your podcasts that there is now genetically engineered salmon, and what you've done is turn on the gene for year-round growth. So how exactly was that found out that you can just very specifically change this gene and the salmon will grow all year round? So how was that discovered?
Well, what they knew is that salmon grew in episodes. They were episodic growers, that you would see them go very quickly during some times a year and very slow during other times of year. And that makes sense. When the water's cold and maybe the food's not as abundant, metabolism slows and you don't grow. What they figured out was that and that was dictated by a kind of an oscillation of growth hormone. You would see it surge at some times and retreat at other times through the season. What they found a way to do is, what if we could turn on growth hormone all the time and put these fish in artificial environments where they didn't have an ecological impact? Well, you could make that same fish grow all year round without a break. And this was in 1989 that they first published this, and it was brilliant at the time. They were able to use a part. So a gene has a couple different parts. It has the parts with the genetic information, but it has another part that's called a promoter, which is like a on and off switch and a volume knob all in one. And so the promoter they got from a different kind of fish that is always on, always active. And whereas the salmon promoter was turning this on and off with the season, this other promoter from this other fish was on all the time. So it meant that the fish that were in these fish farms can get to market size in half the time. That's huge because you're able to get the food faster, high protein, very valuable food source, but do it with less feed, less waste, and less medication and the other stuff that goes into fish farming. So a real score. We'll see it on the shelf soon.
Talking about that, kind of seeing it on the shelf, what's the whole approval process like? I've heard you on a few podcasts say that Europe is kind of slower. So what's kind of both the private industry and government regulations on approving genetically engineered products, whether it's fish or produce?
Well, I mentioned the fish was first done in 1989. and so here we are, 30 years later.
So
and
it's still going.
Still going on. Okay, so anybody who says this is a rubber stamp, it's the world's longest stamping that ever could happen. The bottom line is in animals, it's impossible. Right now, under the current regulatory system, it is just frozen. And they treat animals like drugs. So if you make a single change in an animal's genome, you erase one of those letters, that animal now has to be deregulated as a drug, which means all the safety testing, feeding to animals, animal tests, toxicity tests, tests on clinical trials on humans, it is insurmountable and it's expensive and it can't be done. It just isn't practical. In plants, a little bit different. In plants, it is you change the crop and then different aspects of the crop go through evaluation through different agencies. They go through the FDA to ask, are the products safe to eat? And they do animal studies and other studies. Then it goes through EPA, that is it safe to grow? What are the effects on pollinators? Does it have any other problems in the field, any other issues in the field? And then the USDA to ask questions about invasiveness and how does it perform on the farm? Can it cross with native species? These are all the questions that happen. It takes many, many years to get that approval and millions of dollars. It's really, really expensive, and it keeps, sadly, most small companies and universities out of commercializing this important tool that we can use to feed more people.
You seem to be kind of very outspoken, and you do a lot of public education, a lot of keynote speaking events to where you're kind of trying to educate people about the science behind genetic engineering. I mean, you've been on the Joe Rogan Experience. I've seen many of your TED Talks. I mean, you've got your own podcast, Talking Biotech. So what are some things that you've learned about kind of the whole industry and consumers while you've been trying to educate people? What are some big takeaways that you've gotten?
Well, the biggest takeaway is that it is not so much about education, and that kills me to say that as a professor. People don't respond to more information. Most people have made up their mind. They've decided based upon the people they trust what that is. So whether it's somebody online or a website or a celebrity, they've shaped those decisions about food and farming. Gwyneth Paltrow has much more pull than I do. Dr. Oz, you name it. So this is really what we're up against as scientists and as farmers, is pushing back against a very social wave of what isn't necessarily the best information. So as people have made up their mind, how do I change their mind and how do I get the truth to them? And it's not just about giving them information. It's about becoming more trusted than Gwyneth Paltrow and more trusted than Dr. Oz. And I get that by being accessible. They can email me. They can listen to the podcast. They can send me, an email. I'll write them back right away. That's the kind of way that we're going to change this as scientists, is by building that trust in those connections. And hopefully that'll serve as the way we break through here.
I like that. Yeah. Our podcast a few weeks ago was right above Gwyneth Paltrow's podcast, which I still can't get over the name of her company, Goop, on that whole product line. But I like that you're trying to be accessible to where more and more people can kind of see you and hear your message. I mean, I know the answer to this question, but has there been a lot of backlash towards you and your thoughts on genetic engineering?
Oh yeah, I mean it's but see, this is what it's about. And when I do most of my talks these days, I don't talk about genetic engineering. I talk about how we change people's minds, and I talk about persuasion, and I talk about how we become trusted, and that's the bigger barrier. The information's there. We know the facts already. They're well established. The question now, whether you're talking about genetic engineering or vaccines, or you name it, in vitro fertilization at one time. All of these things are controversial because the public makes it that way, and they don't know who to trust. So they take the safe decision, right? I'm not going to vaccinate, or I'm not going to eat genetically engineered ingredients from genetically engineered crops. I'll take those safe routes. Unfortunately, that hurts other people. And, whether you're getting measles or whether you're someone who's starving in another country because you don't have access to technology, our decisions here make impacts elsewhere. So this is all about trust, and how we build trust is by a big part of it is intimacy. How well do people feel that we care about the same things they care about? And so instead of beating somebody to death with data, I say I worry about my diet. I worry about my niece's diet. I worry about the people who have nothing and are food insecure. That's the kind of stuff. And I do worry about that. That's not just made up. That's why I do what I do. And I don't talk about how I do it. I talk about why I do it. So when you're folks who are against genetic engineering, and you hear me changing hearts and minds by talking about being an independent researcher in a public university, the first thing they're going to do is do anything they can do to tear that down. And it's unfair criticism. It's absolute assaults online. If you Google me, you would never hire me for anything. If you looked on Google Images, after you composed yourself from laughing, you would feel really bad for me. It's that kind of thing that is what they're trying to do, is make me look like somebody you wouldn't want to email or reach out to. And that's their game plan.
Yeah, I follow a lot of people on Instagram or Facebook, and they're people like dairy farmers or just farmers in general. And there's one farmer that I follow. His name is Derek, and his Instagram is TDF Honest Farming, and he basically showcases his day in the life of a dairy farmer. And he'll showcase some of the mean comments. Like, people will give him death threats. They'll say, "Oh, I hope your kids eat tainted meat." And so it's absolutely ridiculous that some of the links that these anti-science and anti-agriculture people will go to kind of make sure that people that people in the ag industry are being seen as the enemy without them having to do their own research. So they're just saying, "Oh, you're a bad guy. I'm not going to change my mind at all."
Yeah. Well, if you want to, if you had 10 hours for your podcast, I could share with you what I've been through, but it's been, when you get a phone call from someone from the FBI, you're out giving a seminar, and they give you instructions about how to think about getting out of a building, identifying exits, being able to find rooms where you can lock yourself in, and places where you can get cell service while you're locked in. Talking to police about that kind of stuff. I had police here the other day because of the tangible threats. My office got broken into at one point. Someone poured coffee all over everything and broke into the computer with a thumb drive. Downloaded a bunch of stuff. Nothing mattered, but these are. But you see, the other day they put my social security number online. They put my home address. They put my bank account information online. It's constant, but this is the price of deciding that you're going to have the courage to tell the truth, and you're going to talk about science in ways that people understand, whether or not some other people may object to that. But that's the tip of the iceberg. I mean, the amount of crud I've been through is amazing. But at the end of the day, and at the end of hopefully 2020 or so, I'll get some apologies and the nonsense will stop.
Man, good Lord. Good on you for keeping up that good fight. I can't imagine, I mean, having your social security number out there, bank account, your office getting broken into. I mean, I'm sure like that's your sanctuary on campus, and just to have somebody break into there and pour coffee everywhere is just good.
That was kind of I just kind of threw my hands up in the air and said, this is stupid. It gets to the point where you're so fed up with it that it almost doesn't matter anymore. And I hate to say that. The thing that bothers me, the only time it does bother me, is when they say things online like he is a wife beater or a child molester or abuses animals, or the stuff they put about me, which they put it all. That kind of stuff is really bad because they build whole stories around this, and they build whole volumes on websites. And if I ever went to be in university leadership again or anything like that, I could never do it, because any university is, they would be considering me very strongly based on the merits of my research career, my leadership experience. But somebody would write in and say, no, you can't do it. He's a child molesting wife beater, and he's drunk, and a university would say, you know what, we don't want to take a chance with that. You know what I mean? Like, how precautious they are these days. And even companies, I'm kind of, it kind of puts a glass ceiling on me. That's probably the worst thing. The other really bad thing is because when they say something bad about you, here he is poisoning children with his corporate products in back pocket of Monsanto, who, they say things like that. And then they'll say, and here's his address. And it's some idiot in California who does it, who's trying to excite a lone wolf here in Florida to come over and hurt, my animals, or, bother my wife or whatever. And that's really unfair. And they can go after me all they want. Fine, bring it. I'll deal with you. But, leave everybody else alone. And I just don't want to walk home and find, someone whipped a bottle of gas, lit on fire through the window of my house, and that's the kind of stuff I worry about.
Yeah, no, I don't blame you. I mean, once they attack your family and, your house, that's when it gets super personal, and it's not okay. I mean, I feel like, especially in today, there's problems with disagreeing with people. We cannot disagree with people without making it personal, especially on social media and the internet. I mean, if somebody disagrees with you, then they're an idiot. They're a racist. They're, like you said, like a child molester. There seems to be just no end in sight of it. I mean, have you seen anything going on to where people, or maybe the FBI or police departments, are trying to crack down on all this misinformation that just activists are just throwing out there to kind of throw people off of what they're trying to do to help improve the world?
Well, I think that Facebook has started to make some overtures against the anti-vaccination folks. And the anti-genetic engineering ones are not far behind. They work from the same playbook. I'm a little bit less confident that they're going to go after the anti-GE folks anytime soon. Twitter is a hellhole. They've seen the abuse that I endure there and the things people say, and they say, well, just block that account. Well, fine, I block it, but they talk to everybody else saying things about me that aren't true. So the only way to defeat this, the only way to do it, is you have to develop more good media that matters than they can do disparaging work. There's only a few of them. And to be on your podcast, to be on with Rogan or Dr. Drew or any of the other places I've been, that's where we really start to amplify the good stuff that hopefully people will have the filters to be able to say, okay, this guy's not so bad. This is all a bunch of garbage, and I'm going to support this guy going forward. That's what we need more of.
Yeah, absolutely. Instead of just articles written from people's view of you, actually see you and hear you and see your thoughts and what your research does. Then you put a face to it and like, oh yeah, half the stuff out there is garbage. I'm going to actually believe it from him. Man, well, power to you. I wish you the best of luck. I hope all that stuff improves. I can't imagine going through all that. I would have just quit months ago. So seriously, good on you. So moving on to happier topics. Let's talk about your podcast, Talking Biotech podcast. You've covered a lot of really cool stuff. You've covered how HIV prevention in genetically engineered rice, even countering disinformation in places like Africa and their GE crops. So what kind of got you interested? I mean, I know you want to get your message out there, but what are some things that kind of made you start the podcast, and what are your goals with the podcast going forward?
Well, people always said, you should do a podcast. And I was on the radio in high school, and I did a lot of speech and debate stuff in college, and always had a knack to be able to talk to people, and enjoyed kind of developing interview skills through time. And I didn't want to do a podcast. I saw it being as a medium that fit me perfectly. People would say, oh, you've got to do it. And I resisted. I might have been one of the first ones otherwise. So I did start doing a podcast where I did one called the Vern Blaythek Science Power Hour with your host, Vern Blaythek. And I did the funny voice. And I interviewed people in the voice like this about some serious scientific topic. And it was actually kind of funny. It wasn't that funny, but it was medium funny. And one particular journalist I asked her to be on as Folta. I said, hey, could you be on this podcast? I do it as a kind of a funny voice, and we do it that way. And she thought this was the biggest conspiracy of all time, and wrote a horrible article about me being not transparent and deceptive and all. And I was just doing a funny podcast. And if you look at, sciencepowerhour.com, I think it's all gone now, but any of the screenshots from it, you could see it was just like a hilarious, stupid kind of Devo-esque, parody of the, Coast to Coast AM at night, that weirdo UFO show overnight. And after that went down, I did Talking Biotech and said, I'm just going to do this as me, and here we go. And that's 5 years ago now, or 4 years ago now, 4.5. And so that was what really got me into it. And I've just loved the idea that every week now I'm getting companies calling me and saying, can we be on your podcast? And I have to tell them, well, we can't do it as a commercial. We can do it as talking about your technology. So now I got people calling me saying we need to be on. We get between 3,500 and 5,000 downloads a week, which is great for a stupid podcast with me on it. And going forward, I think we're just going to keep doing what we're doing. Maybe some new kinds of media that I'm playing with. I have a really cool idea or two that we're going to do, but look forward to more media, more video that'll come from some live things we're going to do, as well as some interesting ways to rate the Netflix videos and that swamp.
Nice. There you go. Yeah, I've heard more and more people are going to podcasts now, especially for news. And I mean, just the whole radio content is really cool. And I mean, especially if y'all go to YouTube, a lot of people love YouTube videos. So we'll be looking for videos on there as well. That's really cool. Yeah. Listen to some of your podcasts are really cool, just to kind of get an understanding of kind of your research and your grasp on all of this stuff. They're really good to listen to. And we'll be sure to link them in our little description of this episode. Random and off the cuff, I really would get your answer on this. What are your thoughts on the non-GMO product verified label?
Oh boy. So the reason I don't like it is because it's disingenuous, and it was started not because it was there to inform people. It started as a way to polarize people. And it was it was people who were in the, natural foods movement, whatever that means, who decided that they would create this label. And since you couldn't get labeling for contains genetic, ingredients from genetic engineered crops, you could put this non-GMO project sticker on things. I just think it's disingenuous because they put it on things where there is no genetic engineered product. And then they equate it with risk on their website and their media, as do others. They say, well, if you don't see this, you're going to get cancer. And if you don't see this, your kids are going to become autistic. And they use it to lay the foundation of false information. And that's something I can't stand for.
Yeah, totally agree. The one that always kind of drives me nuts is the pink Himalayan sea salt that will have the non-GMO product verified label on there. I'm like, this is a mineral. You just get it from the earth and that's it. Like, you don't genetically engineer salt.
Yeah, it's a great example. My favorites are the non-GMO water. And
I have not seen that one yet.
Oh yeah, and the non-GMO kitty litter is a really good one. And I always thought, but this non-GMO project, they make money hand over fist by licensing out this sticker as package decoration to different organizations. And I saw one thing, it was in like a smaller health food store, one small brand. They made a non-GMO project sticker that looked exactly like that one, only with a ladybug on it, and it was a little bit different because they didn't want to pay the royalties to this crooked company to be able to use that label. So that was kind of cool. And I did a blog once on Medium about the non-ghost project. And it was about a realtor who couldn't sell a house that was the same as every other house in the neighborhood, but he wanted to get a little extra money for it. So he put a non-ghost project sticker on it. It's certified to be specter-free. And anybody who knows about science knows that, there's no ghosts, there's nothing like that. But to a certain number of people who believe in superstitious science-free thinking, that meant a lot. And he sold the house the next day. And it's the same thing. It's protecting you from nothing, yet it scares a significant number of people away from lower cost, perfectly fine food.
Yeah, exactly. They're going to see the product that says non-GMO and be like, oh, well, anything that does have GMOs in it is obviously going to be bad. So let me buy the non-GMO product and save our health. It might be a little bit more money, but it's an investment. And have you seen I don't know if it's out on anything yet, but the USDA has made this new GMO food label where it just has like a little field and it says bioengineered on it. Have you seen that yet?
Oh, sure. Yeah. I was front and center in that whole discussion of how to do that, and nobody listens to me. I thought it's a horrible idea, as it officially means nothing to everybody.
Why do you think it's a bad idea?
Well, it still designates certain foods as having implied risk. And to some people, that's what that may mean. To other people, the term bioengineered, I mean, what does that mean? Even though a scientist, it doesn't necessarily mean anything. So it's really puts the USDA in a funny place. They've capitulated to the demands of food terrorists to put a decoration on a package, and then they put one on there that is easily misinterpreted or misunderstood. Just not clear in terms of how we tell the truth about food.
So going forward, what do you see? And I mean, you said it talks the industry goes very, very fast. Long term, like 5, 10, 20 years, what do you see as the future of genetic engineering? Do you have any really cool thoughts, or do you have any concerns about kind of where it's going?
Oh, wow. That's a great question, because this thing is moving so fast that a 20-year time horizon is not even in the cards. 5 years ago, we could not have predicted gene editing working as well as it is. And new types of nucleases, so what they call site-directed nucleases. So site-directed nuclease means that it can go into the DNA, which you have, let's say, 3.6 billion bases, 3.6 billion letters. And they give you a perspective on that. That's if 3.6 billion seconds is about 100 years. So you can go back to, August 23rd, 1941 at 1:23 p.m. and 18 seconds. And that would be the resolution of the edits we can make. It's 1 second in 100 years. And we can do that now. And we call this site-directed nucleases. These are getting more precise and better all the time. And what this means is that we can disrupt the genes that cause disease, different diseases. We can change susceptibility in plants to disease. We can change the factors that limit yields. There are so many things that we can do now that we couldn't do 5 or 6 years ago. And the future is coming even faster. And my biggest fear is that the universities won't be able to keep up with companies because there's not enough funding, and things happen at a slightly different pace. And when technology is breaking loose on the order of weeks and months, and we're waiting years, it puts us at serious disadvantage.
Anytime I try to explain kind of genetic engineering with people that aren't in the industry, I kind of bring the conversation to carrots and how carrots were first purple and they weren't orange, and they were only bred to be orange later on down the road. I think in the Dutch did it in the 17th century, I believe. What would you say is the main difference between kind of cultivating carrots, kind of how they did back then, to where it wasn't technically genetic engineering, to genetically engineering plants now. So how would you kind of compare and contrast those two procedures?
Yeah, so the way I always think about it is, engineering by definition is the use of math and science to change structure and performance of something, blah, 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 right? So I don't know that I would call traditional breeding engineering, because let's look at it this way. The plants that were here on this planet 20, 30,000 years ago were not that useful for food. And people were hunting and gathering, and they were wandering around in the savannas and looking, flipping over rocks and eating grubs and beetles and anything you could find. And it was a horrible existence. If you could find some tender roots or shoots or something, you would eat them, or flowers that wouldn't kill you. You would eat them. And eventually humans they figured out what seeds were, and that if you took some seeds home, you could grow this stuff at home. And that changed everything, because now you've taken those seeds out of their ecological context, and you planted maybe some seeds on your space, or maybe they just happened there because you threw out the garbage and you didn't eat the seeds, and then the plants grew and people thought, oh wow, we actually can move our food. And let's say you have a bunch of these seeds growing, and the next year an insect attack comes and all of them die except for one. And that's because it had genetics that allowed it to survive. Now that one's the only one that makes seeds. And the next season, you've got an insect-resistant crop. Humans just participated in genetic modification. And that idea of genetic modification through time was humans improving plants by breeding and selection. And we didn't even know we were doing it, but we were dramatically changing the genetics of crops that were becoming better for us and less likely to survive in the wild. We did this for 10,000 years, and in the 1900s got very good at making crosses and selective breeding and picking the right parents to make better offspring. And in the 1980s and 90s and now, we can now move genes one at a time with great resolution and surgically to be able to make plants that can survive very well. And so we're doing the same. This is engineering, though. Back then, I think it was circumstance, it was dumb luck, it was educated guesses through plant breeding times, through the 1800s, 1900s, until the 70s, 80s, 90s, even now with some crops. But now we have the opportunity to do very careful marker-assisted breeding or genome-guided breeding, or we can do a lot of more stuff with great precision now. Engineering is like the gene editing, or like I said before, the transgenic technology where we can move one gene or erase one letter. That's the big difference. It just is much more precise and much more directed and really much more safe.
Okay, that makes much more sense then. That kind of helps me understand it a little bit more. So what are some things that people can do to support the science behind genetic engineering and just support science in general? Because I know there's a lot of misinformation out there. So what can consumers and even farmers do to better support science education when it comes to genetic engineering?
Yeah, the easiest thing farmers in North America can do is share your stories. Talk about why you do what you do. Take pictures of the farming operation. Show the crops you grow. To a farmer, a seedling coming out of the ground is like, big deal. But to someone online who never has been on a farm, that's the closest they've ever been. And we have to share those stories. Talk about your spraying plants with an herbicide, spraying to limit weeds with an herbicide that's 99.99% water, and that your kids can go in that field 5 minutes after you spray and it's safe. This is the kind of stuff you need to share. For others, just the average person, learn the stories of how technology, and it can be genetic engineering, it can be cell phones, it can be medicine, I don't care. Learn how technology can help the people in the most need. And to me, genetic engineering can make profound impacts on people in profound food insecurity. The people 21,000 will die today because of lacking a trace element in their diet. It's not just calories. It may be a little tiny bit of zinc, a tiny bit of iron, a tiny bit of vitamin A. And we have genetic solutions that can fix that. But because of the pushback and the non-GMO stickers and the people who say it's poison, folks in places like Uganda will tell me, well, if it's not good enough for the Europeans, why is it good enough for me? And I have to say, well, I don't know how to explain that. Know the stories and know how technology can help people, and share those stories, because that's the only way the stuff will ever get to them.
I like it. That's really good advice. Tell us a little bit more about the Uganda banana. I listened to one of your podcasts, and it's called Matoke, if that's correct. And it had more vitamin A, and it's kind of been going back and forth about whether it's going to be officially put in use. So tell us a little bit more about the Matoke banana in Uganda.
Yeah, this was one of the most emotional times of my life. Most people talk about graduating school or birth of a child or getting married. Mine was standing in a banana field in Africa. I mean, this was really, really crazy. So I was in the Kiwanda Research Park, which is a long, bumpy road ride outside of Kampala, Uganda. And what they have there is African scientists created a banana, which they call matoke. It's kind of much more of a plantain. And they use this for a foundation of every meal. The matoke banana is the rice in a Chinese dish, for instance. It's the foundation, the starch in that meal. And it's culturally what they call food. If you give someone that meal without the matoke, they go, well, that's not food. Well, the problem they have in the lakes region of Africa is vitamin A deficiency. And we do a nice job in the West with eating vitamin A. We get plenty of it from fruits and vegetables. And Mom always said eat carrots because they're good for your vision. And she was right. They're full of something called beta carotene, that orange pigment. Bananas don't make much of that. There's one banana that does, and it's called the Fe banana, Fe-I, and it's grown in Fiji. The problem is you can't cross bananas very easily, right? They don't make seeds. We have them sterile. They have too many chromosomes, whatever. So what scientists did was take the genes that were from that Fiji banana and put them into the matoke banana. And now you have a matoke banana, this, traditional African banana that everybody wants, that makes vitamin A, beta carotene anyway. The body converts it to vitamin A. That matters because something like 35% of children in that area suffer from vitamin A blindness. And you have a deficiency of vitamin A in the diet. You first go blind as a child. You usually die before 5 from immune system failure, diarrhea, and all kinds of other problems. African scientists, Dr. Priver Namanya, along with a guy named Dr. James Dale from Australia, and Lena Tripathi from, she was in Kenya, they made this banana with that Fiji banana gene. And I was in the field with her, with Priver Namanya, Dr. Namanya, and she went up in the tree and she got a banana down and she cut it in half and it was orange. And here is the solution to help those blind kids. It's right there. It's right there, and it's growing, and it's great, and it's perfect, and it's done by scientists from Uganda and Kenya, and they're going to give it away. But they can't because it's genetically engineered, and the government has no rules for how to release and test a genetically engineered product. Their parliament, they're kind of the wealthy guys who have some food, and they say, well, we don't need this. The Europeans don't need it, neither do we. Look in the United States. People don't want this. It's only the corporations shoving it down our throats. No, it's not. It's Priver Namanya. It's Dr. Namanya. And, so this to me is really horrible, because here is a place where I saw the problem in children who are blind, and I saw the solution on the same day. And the difference is they're on different sides of a barbed wire fence. And as a scientist, it rips your heart out to see that. And I'll never forget that.
Man, I can imagine. I mean, you have the answer. You've created the answer. You can simply solve the problems. And because of bureaucracy and just these random government laws, you can't do it. Man.
Well, and also all of the people who say it's poison and that it's a problem and that it's going to hurt people. The Greenpeaces are alive and well in Uganda saying that if you eat this, you will get cancer. In many countries around Africa, they talk about orange beta carotene and these are places which are not accepting of people's choices in terms of mates and things, where they'll say that it'll turn you homosexual, which in many places is culturally something that has not been acceptable yet.
Right.
And they say this very clearly on the radio and in other media, and it pushes back against something that can help kids. And all of this starts in the West.
Yeah, man, that kind of makes it all you can see the bigger picture that people, when they spread misinformation online, because they just click it sounds interesting and they'll share it, that it's having drastic impacts on people on the other side of the world where, they're like, these people in Uganda can't have that banana. So you're going to have countless kids get sick or die because there's just so much misinformation out there. That's really heartbreaking.
Yeah. And it was horrible to stand there in the middle of those trees because they were big and beautiful, and it was getting dark really fast when I was there. But you stood underneath this canopy of trees and you said, how can I get one out?
Yeah.
There's a guy with a rifle at the gate and you sign in and sign out. But, you just think if there was just a way to, anything I could do in my power, my stupid, insignificant power to be able to fix this. And all I can do is talk to you about it and hope that you get a jillion listeners and they share the story. That's the way we get justice for people. And all these folks who say, it's all about food justice and, Monsanto ruling the food supply. No, it's not. It's about justice is about getting solutions that matter and innovations that can help people to the people they're designed to help. That's what justice is about. Totally
agree. Have you heard any updates this year or the past couple of weeks on that project? Is it still just not going through?
Well, back when I was there, part of the reason I was there was to meet with the science minister and answer his questions and to get him ready to go. And a brilliant guy. He was a medical doctor, had a lot of questions, but he was ready to go. And we got him all briefed, and he went in and he got the change so that the legislature could begin to come up with rules to change it. And I got the text message from him, and I cried. I was so happy that he got the change to start this. And a few weeks later, the president vetoed it.
Oh, man.
and then I just went and had a beer and decided that I was.
That's a roller coaster of emotions. It's finally going to go through, and then nope, vetoed.
Oh no, and and all the kids who had their vision was getting a little bit lousy, and they went, oh geez. But no, seriously, not to make light of it. It was the president's wife who talked him into it. And so we're once again have people with means and affluence, in these countries where there's many poor who are making decisions that hurt people because they're afraid of science, and that's where we gotta fix it.
Yeah, all about improving science literacy here, at home and away. Man, that's sombering. Well, Dr. Folta, this has been a really cool conversation. Learning about all things about genetic engineering. If people want to follow you, they can go to your podcast. It's Talking Biotech Podcast. What are you guys, twice a week or once weekly?
Oh, geez, once a week is enough.
There you go, once a week. Yeah, I found it on Spotify. It's on iTunes. It's everywhere. Yeah. If people want to follow more of your work, where can they go?
Well, I have a blog called Illumination, which is you can find just by Googling Illumination in my name, or kevinfoltablog.com. Also on Twitter, and I'm on Twitter at Kevin Folta. That's a good place to find me. And most importantly, reach out if you ever have questions, ever have concerns, or read something that you're unsure about. Share it with me, and maybe we'll put it up on the blog for everyone to understand. I'm a land grant scientist at an important institution here in Florida and in the nation, and my job is to help you. So reach out if I can be of assistance. I mean that very sincerely.
Awesome. I love your transparency. My friend Daniel Leonard told me about you, and I emailed you, and within 5 minutes you were like, yeah, let's do the podcast. So your transparency is awesome. It's very admirable. I appreciate that. Well, we will send as many people we can your way. Dr. Folta, thank you so much. Best of luck in your future and with the future of genetic engineering. We'll be paying close attention.
Cool. And I'll come back on when they approve that Matoki banana, and we'll raise a glass to the people who now get to live their lives with vision and health. It's coming.
Absolutely. Absolutely. I pray it's coming soon. We'll toast a beer whenever that happens. We'll keep you updated, and we'll be listening for you. Well, Dr. Folta, best of luck. Thanks for being on, man.
Yeah, thank you very much. We'll talk to you soon.
All right, do you want the good news or the bad news first? I know, always lead with the bad news. Okay, the bad news is the episode of this podcast that you love, it's over. Yeah, I'm sorry, it's over. Don't you hate that feeling when you finish the latest episode of your favorite podcast and then you don't know what to listen to? Well, I got a show that you should check out. It's called Homesteady, and it's hosted by me, Ost. I live on a homestead with my family, and we live off the land. We grow our own food in our gardens.
We're going cherry picking today. Grab your bucket, get in the car.
We raise livestock for meat and milk.
This week on Homesteady, the pigs are arriving.
We hunt, we fish.
I was almost done hunting. I was just sitting there thinking about climbing down. I looked, twig snapped, took a peek. Oh man, big buck. Got the camera ready.
Wow! Oh, bud! That's the biggest trout we ever got!
If you want to lead a life that's a little bit more self-sufficient, a little bit more sustainable, check out the Homesteady podcast. You'll hear our stories and hopefully be inspired to start some of your own. Homesteady releases a podcast every single week for you to enjoy an adventure in the outdoors. And this show is just one of the fantastic shows that make up the Waypoint Outdoor Collective, the podcast network for outdoorsmen. Click the link in the description below to go to Waypoint Outdoor Collective, download Homesteady, and check out some of the other fantastic podcasts while you're waiting for the latest episode of your favorite one that just finished.